I'm going to do a demo of a new POC for showing or for doing reminders. This is running off the website, so the server it's using is like got 2 Celerons and it cost $150. And because the Programmable Mind doesn't use a neural net, so it doesn't need a GPU to run. It can run on like not very complicated hardware at all, or powerful hardware at all. Uses 35 watts of power. So this is a POC showing how to use a Programmable Mind to do like a reminder kind of thing. A reminder-based voice UI, but I also have a GUI here, so there's a language UI and a GUI. And it's a POC, so it's not like bug-free, and I don't implement everything you could possibly implement because I'm just doing a POC showing the kinds of things that you can do with the Programmable Mind framework. I'm not trying to write a shipping reminder system. My shipping thing is the framework, not the reminder thing. So it's a POC, so keep that in mind. I'm just demoing the kind of stuff you can do. So I use the POC is based off this knowledge module. So the reminders knowledge module. So I wrote this independent of this website here, which is just demonstrating the use of the knowledge module that pre-exists in a website. I mean, it doesn't have to be a website. It can be any kind of app. This is the source code for the website. So when you hook the knowledge module up, so when you use the knowledge module, you hook it up to your local app by using an API. So let's see over here. Let's go to the source code for the knowledge module. Bloop. How many lines is it? 440 lines. So this is the thing that defines the kind of things you can say about reminders. And again, it's a POC, so it doesn't do everything. And if you added more stuff, capabilities in here, they'd automatically, as if you upgraded to the new knowledge module, they get picked up in this web app demo. So this is the API in here. Here's API. Bloop. So the semantics in this knowledge module will call the API to do stuff. So here's the stuff the API can do. In this one, it's just saving it to this local data structure in the knowledge module, and that's so that I can write unit tests and stuff and have them work. And then over in the app, I've overridden some of the members to store the reminders. Instead of storing it in whatever data structure the knowledge module is using, I'm going to store them in my own local data structure. In this case, I just shoved them into React properties. In a real system, you run this in a middleware and store the data in a MongoDB. Or you could write a standalone like exe and run it against a local database. You just have to run the JavaScript layer as an embedded program. Anyway, so this shows how to connect the knowledge module that came from here into the app that's over here, so that the knowledge module can use the local data structures and not be stuck with whatever it happened to use. That's all I wanted to say about that. Oh, and this reminders thing uses 2 other knowledge modules. One is this date time selectors one. It knows about dates. Again, it's a POC, so I've finished writing everything you could do. So this is the kind of stuff you can say about the reminder over here. Because the reminders knowledge module included that date time selectors one, you could say this kind of stuff. And the other thing it includes is this asking one that knows about allows you to create motivations to find for the language layer to find out things from the user, like what the date is or whatever. So let's go to the demo. So if you click here, these are just all test sentences that came from the the integration tests, so now that I know they all work. So we'll just start with an easy one. Remind me to go to Regina. So this question is happening because the reminder code called the asking knowledge module to say, find out when I should go to Regina. And I can answer, I don't know, October 5th, 2027. And then to demo that this is not just taking in a... So when it did the sentence, backing this UI, which is shown here, is actually JSON data structures that has more information that's being shown in the UI. And then this is just to demonstrate that it did a calculation of, it took the, whatever the interpretation of the utterance was, mapped into a JSON data structure. It's able to convert that into a calculation. So this is actually a JSON data object that's the next time that the reminder should go off. So that's just to show that it's actually doing actual calculations. It's not just generating some sort of language-based data structure that has no practical applicability. And then we got, so I'll show the integration of the GUI. So there's two things interacting with the data, the reminders data. One is the graphical user interface, and the other is the language-based user interface. Let me add a new user, Fred, and I can say add Fred. So I just made that mean to add Fred as someone who's going to get reminded. I mean, you could also, I didn't implement it, but you could also make it say, also remind Fred or other language things. I didn't do that because it's just a POC. If you're really trying to ship this reminder thing, you'd have a dev team and they'd have use cases and they'd do all that kind of businessy stuff. Anyway, so this also demonstrates that I used the GUI here to add a new user to the data structures, and then the language layer was able to access the data structures because the language layer is in the programmable mind and it's written directly against the API, which knows about the data structures. When I said add Fred, it knew Fred was an employee and added it to the people to be notified. So this is different than a neural net-based system. In a neural net-based system, the current state of the language layer is going to be stored in a state vector, which is a bunch of numbers that are sort of correspond to the current, to whatever graph the neural net happens to represent. And so you need a way to sync the data structures that this program operates against with the state vector of the neural net. Plus, the neural net needs a GPU. This thing isn't using a GPU. Half of it's running in the browser. I happen to write the backend in Python, but if I wrote it in Node, I could run the entire thing in a browser for sure. But I didn't happen to do that. Too bad. So it doesn't need, but anyway, the backend is not running against GPU. It doesn't need that much power. Because like with neural nets, you're really kind of like doing a search, and it's building its answer off a bunch of little like fractally bits. It puts them together into the answer. And so then you need a lot of computational power. Whereas the programmable mind, you're directly programming it with what the answer is. So it isn't really doing a search. It's doing a computation. The theory is based on a generalization of the operator precedence parsers. So it's essentially doing the same computation as you do if you use the shunting yard algorithm to do like 1 + 3 × 2, like in a calculator in the 70s. It's doing that calculation, but it's generalized. I couldn't use the shunting yard algorithm, so I had to use a different algorithm because I also had to handle ambiguity. But anyway, it's doing a direct calculation, the same as like 1 plus 1 times 3 would the same as you'd use operator precedence to do that. So that's why it doesn't need as much computational power. It's not really, and that's why it's like more effective against this particular solution where you have like an API where there's not going to be any training data for a neural net to learn how to call the API or what happens to currently be in the database. There's no training data for that. There's no way for it to get that. So you really need to be able to program directly against the API, which the Programmable Mind lets you do. So let's do more stuff. Remind me. So what should I remind you to do? So then I'll just say on January 22nd, what is next year? 2026. Bloop. So I said remind me, and so then that started a dialogue where it knows I want to be reminded of something at some date. So then it said, what should I remind you to do? But I answered on the date, and because it uses this knowledge module, which one is that? Asking. So when I said remind me, then this knowledge module, the reminders one, created two motivations to know what is the date and what do you want to be reminded to do. And so then when I answered the date, it was able to go, oh, I wanted to know two things, what to do and the date. So the user told me the date, so that's the date. It's even though I asked for what do you want to remind me to remind you to do, they gave me the date, so that's the date. That's not what I wanted to be reminded about. So that just shows the dialogue system. It's sort of nascent. It isn't as sophisticated as I want it to be, but I got it going. So it needs way more work, but it should be fun. So I don't know. Go to Moose Jaw. Go to Moose Jaw. That's where Burton Cummings is. Yeah, so that's that. And then I also hooked up the UI knowledge module. I demoed that in the menus one and maybe Pip-Boy, I can't remember. So the UI knowledge module lets you say things about the UI. Where's that? Bloop. Up, down, select, this, that. I think I only implemented up and down. I didn't implement select and cancel and all that. But I could. If I wanted to, it'd be implemented in... this is the API for the web app. Yeah, so I didn't implement any of that because it's just a POC, right? I only implemented move. But it's a Programmable Mind. If you want to implement that and it means something in your app, well, implement that. It's programmable. So I'll just demo that up. And then, remind me to go to France. What can I say? I can't even remember what I can say. Let's just pick one from the list. Remind me to go to Regina Monday at 10 a.m. I'm going to Regina twice. I'm from Regina. So up to, so I can go up to, so that's showing using the user interface or the language user interface to change the state of the program. And I'm going to use the graphical user interface to change the state of the program. I didn't tell the language user interface anything. Now if I say up one, up one, it moved to here. Whereas the last time the language user interface saw anything, it was here. Then I used the GUI to click there. And then when I said up one, it went here. It didn't try to go up one from there. So that's just, again, just demoing how the language user interface and the graphical user interface, they're hitting the exact same back-end data, which if it was a neural net, you'd have your own separate state vector. So how do you tell it, when you click around in the UI, how do you tell the neural net, oh, well, things have changed from the last time we talked? Plus, it's like if the back-end database was like Mongo, how the neural net can't even scan that to know the state of anything. It wouldn't even know how to call the API. There's no training data. So that was just more demoing of showing the tight integration between the language layer and the graphical layer. Did I do everything? Yeah, I think so. How long have I been going? I don't know. Yeah, so as I add more stuff to this date time selector, like I'll probably do other POCs and I'll add more stuff to this in the future. As I add more stuff here, it will automatically get picked up here by this reminder one. As I make this, oh, I didn't demonstrate, never mind. Okay, well, let me do that. Remind me to go to France. Bloop. Then I can say never mind. And so then it goes, so that came from the asking knowledge module. It knows how to do never mind. And over here, what is this? This is the knowledge module code. Is this the knowledge module? Yeah, this is knowledge module code for this, the reminders knowledge module. So over here, there's on never mind. This is this query thing. Let's show that query. So this is where, this is in the semantic for remind me. So I created two query. I called the ask knowledge module to create two queries. And then over here is the implementation of this query function, which returns the how you define a question. Anyway, so this is the on never mind handler. So it calls the API to do the delete. And so then in the knowledge module, this is going to call the local value, which just updates it locally. But then over in my application, I've defined delete in here somewhere. What was it called? Delete. Delete. I have to find it. Remove. Oh, I must implement it in some other way. I forget how I implemented it. Maybe I implement it with set props. Anyway, so this delete over here has somehow been rewritten to, I guess I could look over here. Delete reminder. Yeah, so this is, the delete here is calling this reminders and then doing set reminders, which is over here in the application. I've updated set reminders. Set reminders. Yeah, I've updated set reminders to call a React and Redux store. So that's how it's connecting to the local data through the API. But I didn't have to rewrite all the other stuff or any of the language stuff. Okay, so I think I demoed everything. Did I demo everything? Yes. And so as more stuff is added to these, as I do other POCs, I'll add more stuff. I probably won't do any more to this, but to this one and this date one and this. As I add more stuff, they'll become available in this thing. So we'll call that a demo. Yeah, let's call that a demo.